All right, so please remember to check Unit 6 folder or Week 6 folder for all the Word document with all the questions for you to practice on for the midterm. This is just a short review lesson to prepare you for the midterm. So, yes, we are having an exam. Okay, so starting at the beginning, what is the difference between a soil horizon and a profile? So remember, horizon is a single layer within the soil profile. So the profile is the collective, and a horizon is one particular layer within that profile. So you have your O layer for organic, let's say, or we have our parent material layer. So a horizon is a component, the profile is the whole thing. How does parent material influence soil characteristics? So we talked about granite being acidic. So this is a granite rock in northern Ontario, and the soils there tend to be acidic, where this is limestone on the Niagara Escarpment, where the soils tend to be a little more alkaline because of the limestone component that the soil's starting from. In our lab, we discussed how compaction, and you did your lab reports on how compaction affects soil and aeration specifically. So on the left, we have, let's say, for example, 50-50 air and water in the soil, but after compaction, we end up with 80% water and 20% air. The percentage doesn't matter. It's just that the whole point is the soil can hold more water. If you look at the total amount of water that versus this, it can hold more water after than it did before, but it has less air. So there's always this, unfortunately with soil, there's always this balance, right? Remember I had a picture of a teeter-totter between porosity and aeration. So we can't have everything, right? We got to have a compromise. So we need the right amount of air, but we have to have the right amount of water holding capacity. When we sub-irrigate, that means watering from below. So sometimes people put their African violets in water or their orchids, they soak from underneath. How does the water get in? It gets in through capillary action, right? This paper towel is wicking up. Actually, in this case, it's wicking down, but it doesn't matter. The same thing goes in the other direction. So if you have a plant sitting in water, it's going to wick water up through capillary action into the tight micropore spaces. What's the difference between gravitational and capillary water? So remember, let's say we fully saturate a pot, all right? It's fully saturated with water, and we let it drain. Okay, so over here we let all the water that is going to drain out, and now it is at field capacity. The water has basically stopped dripping. That's the most water that volume of soil can hold. So at that point, this part, the water that's fallen out, is the gravitational water, and the water that's still in the soil is your capillary water. Okay, so that helps you remember the difference. Sometimes we call this field capacity, sometimes we call it capillary water. Same thing. What is the difference between adhesion and cohesion water? So remember, I had a trick to remember this. Ad is for adhere or stick. So adhesion is water that is stuck to the soil surface, the particle. So this is your rocky bit, and the adhesion water is right on the immediate surface of that rocky bit. And the cohesion water is further out. So cohesion water, plants can access, but adhesion water, they cannot. Okay, so that's two differences, their location and whether plants can access it or not. All right, so again, define field capacity. So we already did that on the one slide. So that is when all pore space is occupied by water and allowed to drain. Total porosity with respect to soil properties, which one is that? Total porosity is going to be this one, because all the pores are occupied Not because they're in water, but that's just how we measure it, right? So by putting water in this sample, we've measured all the pore spaces. That's our total pore space. After we let the water drain, we're left with our field capacity, right? And then, of course, once the cohesion water is used and we're left with just adhesion water, we're at the wilting point. And I just kind of gave the answer to that. Is adhesion water considered available to plant roots? And the answer is no. Is cohesion water considered available to plant roots? And the answer is yes. Then we talked about pots and using shallow pots like a pan for bulbs and why that was useful. And this picture here helps demonstrate, right? If you fill all of these pots right to the surface, all the way to the top, and then let them drain, just like in the sponge lab, the water drains down until you're left with gravitational water and adhesion and cohesion water forces pulling up and pulling down and being in a balance. And that always ends up being the same amount for that particular soil type. So the idea is that in this particular example, there is a lot more water as a percentage of the total volume available in the shallower pot than in the tall pot. So it stands to reason that plants that like their roots to have more moisture, like bulbs, are better off planted in a shallow pot like this or like this. Man, my drawing's terrible today. Sorry about that. All right, then we talked about textural boundary layers, right? And how do they protect against excess soil water, right? So here, this green is kept green because it's on a perched water table with irrigation, which allows the water to be collected and only used in the green area. But if for some reason there happened to be a major deluge of rain, the water, once it gets above saturation, will then slowly leak out into the textural layer. So it acts like a check valve. So the water, the green, is kept nice and happy and irrigated. And in the event of excess water, which seems unlikely in this location, the textural boundary layer will allow it to drain. Check this out. These people flew in to go golfing. I don't know. That's just wrong. That's wrong. What are the three phases of soil? All right, so my little goofy pictures here. We've got air, water, and solids. So normally 25, 25, and 50. But that doesn't really, it changes all the time depending on the soil, but we'd like to say that. That's kind of ideal. What does CLORPT represent? Remember we talked at the very beginning about CLORPT? That was an acronym to help you remember how soil is formed. So climate, organisms, relief, parent material, and time. Climate being wind, rain, ice, freezing, all that stuff. Water erosion, how it slowly wears away at the rocks. And organisms are the microorganisms that are slowly working on the material to break it down into smaller pieces. Relief talks about, mountains and erosion from falling, or water flowing down, or rivers running across. Parent material we discussed already, right? That's the type of rock that's at the bedrock, the base. That's what is responsible for the type of soil you see in that native environment. And then, of course, time, because it takes a really long time for all of this to happen. These are geological scales of time here. Organic soils forming quickly and mineral soils taking a lot longer to form. How does soil change as you move from topsoil to subsoil? So if you remember our typical profiles, we start with more organic content at the top, right? And as you move down to the parent material, it goes to larger and larger and larger particle size until you're in a solid bedrock. That's probably the simplest example of how to think about how your soil changes as you go deeper. It's the profiles. If a soil can form a ribbon, so remember ribbon tests, if you can form a ribbon without crumbling or cracking, what type of soil is it? Well, anything with more than, where's the clay, right? You get clay, anything more than 40%. Actually, more than 20, technically, we start to get into all clay classifications. 20, 25. Everything above here has got some sort of clay prefix. Describe how water would move from a dripper into soil with lots of macropores. So this is the comparison between macropores and micropores. If you remember, we had a slide that showed a soil and a dripper, and on this let's say we had sand, and over here we had clay. Wow, I can't write to save my life with a mouse. And the sand, the water runs deep because it's got lots of macropores, so gravitational forces pull the water quicker than it can spread sideways. Whereas in clay, because it has lots of micropores and not a lot of macropores, the water spreads sideways much more than it would go down because gravitational forces are weak relative to adhesion and cohesion. Name 3 broad groups of species responsible for decomposing organic matter. So this is getting into microorganisms and whatnot in soil. Bacteria, protozoa, and fungi. Right? 3 broad group species that I will be looking for. What do decomposers need to survive? Here's my hint. What do you need to survive? Again, sometimes people get a little panicked in an exam. Just think logically, right? These are living things on our planet, so they need air and water and food. What role do protozoa play in the decomposition process? So remember, bacteria do all the mineralization and heavy lifting of converting nutrients into converting organic matter into nutrients that plants can use. And protozoa come along and eat the bacteria, basically cracking them open and releasing the nutrients. So protozoa play a very pivotal role in getting those nutrients out and available to the plants. Do bacteria decompose fresh or old, dry plant matter? So bacteria always decompose fresh or what we call green things, whereas fungi are what decompose dry plant material, like leaves and bark and logs and twigs, that kind of stuff. What is the key biological difference between grassland soil and forest soil? So we've covered this a number of times. Grassland is bacterially dominated and forest soil is fungally dominated. What is the principal benefit of using compost tea? So I find a lot of students kind of get confused in this section. It really is not meant to be that complicated. Compost tea, all we're doing is we're taking a small sample of soil, adding it to some water, right? Bubbling it up, and we're getting the, let's say the population of microorganisms is 10 here. That's just an arbitrary number. And after about 24 to 48 hours, we have now 1,000 in here. So we've increased the population significantly of microorganisms, both bacteria and protozoas. And then we take the liquid and we dump it onto our soil, which has to have some organic components, nutrients that are waiting to be mineralized, right? So let's say you've added some sheep's manure to your garden or something like that. There's a reserve of nutrients there, but they have yet to be mineralized in order to make the nutrients available. And we know that it takes time. We speed that up by adding compost tea. Then the larger number of microorganisms are in your soil and they will mineralize the nutrients quicker. So compost tea really is just to accelerate the decomposition process so that nutrients are made more available to our plants at a faster pace. How does particle size affect compost? If you had to eat a steak in one bite, you would probably have a really hard time doing it. But if someone gave it to you, this is going to sound gross, but blended into a soup and you just sucked it up with a straw, it would go pretty quickly. So particle size, the smaller the particle, the more surface area, the easier it is for bacteria to break down the components. So often shredding is helpful in accelerating that process. What is an ideal size for a compost bin and why? So again, this is for basically home or market garden size. 3 feet by 3 feet by 3 feet to 4 feet by 4 feet by 4 feet. And why was that? Because it gives us the critical mass for temperature without compromising oxygen's ability to get into it. If it gets too big, you can get, the center can become anaerobic, and we slow down the entire process and also risk having the anaerobic bacteria convert nutrients into gases which evaporate, leaving our compost less nutritious. All right, what's next? What are the carbons in compost used for? Carbons are basically carbohydrates. They're fuel, right? Think about what we do. Potatoes, rice, I don't know, unless you're on the Atkins diet, then I'm not sure what. Then you're getting your carbon from connective tissue or something. What is nitrogen for? It's used for making protein. Protein. It's an important component of living organisms. Without protein, we don't have life. Again, sorry for my writing. And the ratio, why is it important? Because we need enough nitrogen to make protein, but we need lots of carbohydrates. And if we have too much of one, then the organisms slow down and we don't get a hot enough environment. If we have too much nitrogen and not enough carbon, we encourage the growth of the wrong kind of bacteria, and we end up losing nutrients out of our compost. So important to get that ratio, and it is roughly 30 to 1. What is the, oh yeah, there we go. What is the ideal carbon-nitrogen ratio? 30 to 1. What distinguishes greens from browns in compost ingredients? Oops, missed that one. I can't go back this dumb thing, but greens are recently alive and browns have been dead and decaying already for a while. I think we got that figured out. And where does the heat in active compost come from? It comes from all the metabolic activity of the organisms that are in the center of that compost. Look at the steam coming off in this picture. It gets really hot. A properly done compost gets hot enough that you do not want to keep your hand in there for very long. So that's all from the metabolic activity of those thermophile bacteria. And that's the important part because that's what sterilizes the compost. Right? That's the next thing. So heat helps pasteurize it. It kills off weed seeds, pathogens, eggs, larvae, everything except a lot of plant viruses are pretty resistant to the temperatures that compost perceives. So you definitely don't want to throw virus-infected plants into your compost because guess what happens next year? Same virus in your tomatoes and cucumbers, so don't do that. How does vermicompost differ from regular compost? This is more recent, so it should be easier to remember. Vermicompost, first of all, it does not achieve high temperature, so it doesn't have pasteurization. But because of the action of the worms and the ideal environment, they have much more nutrients available. There's a lot more bacteria. It's kind of like compost and compost tea all happening at once. So you get lots of mineralization happening. So compost tea typically has a higher nutrient profile. I did forget to mention in that class, in that folder there's a whole bunch of soil analyses reports you could probably look at if you're curious, that shows you the percentages of nitrogen, phosphorus, potassium, and whatnot. Anywhere around, nitrogen's around 2% in most of the vermicompost, which is pretty good, where a lot of compost is sitting at around the 1% mark. So what else differs with vermicompost? It has higher water holding capacity than regular compost. It's a bit denser. What are the key ingredients for a successful vermicompost? Worms, that's obvious, but again, sometimes students forget the obvious. Oxygen, water, and bedding material, and food. Although technically these are really the same, but I'm separating them to separate proteins or browns and greens. Bedding material is important. There is another ingredient I did mention in class, and I might as well say it one more time just to make sure we're on the same page. But oftentimes you have to add some calcium, some form of calcium, as the worms, they need calcium, but also provides some grit for them to break down particles in your vermicompost. How do we know when vermicompost is ready for harvest? How do we know? Well, the bedding plant material should be gone. The food that you've been giving them is gone. So maybe when the bedding material is gone, you stop feeding them and you wait for that food to finally be gone. And often at that point, what you see in your tray is a dark soil that was known as castings. It's a nice, dark, dense soil. What could be wrong with your vermicompost if you open it and the worms are crawling on the surface? So normally the worms are just below the surface. It means it could be too wet and they're looking for oxygen. It could be too hot, so they have to get out of the compost. Or there's just not enough food and they're running around trying to find something to eat. Okay, so with respect to your midterm, I've outlined the structure for the exam on this slide just to help you with some clarity. It will be mostly multiple choice with some true false. A couple of short answer questions, and this is important. Keep in mind, if there's the number of marks dictate how many points I'm looking for, right? So if I'm saying what are the 3 components of soil, that's easy. But if I say what are the components of soil and there's 3 marks, I'm looking for 3 things: air, water, solids. So keep that in mind when you're writing the exam. There is only 1 attempt on the exam. Sorry, those are college rules. Do your best, sit down, give yourself enough time and space to calmly go about the exam. I have a larger window of time available to accommodate people's schedules. Wait for the announcement and that'll give you an idea of exactly when it will be available. The exam is presented as 1 question at a time and the questions are randomized. So I do not encourage you to sit beside someone, don't have an exam date and go over to your buddies to write the exam together, because you're going to get really confused because you're both going to start running out of time and be looking at different questions and frantically searching up the answers when you could be a little more organized and do it yourself. Do not do this exam on your phone. Blackboard has had issues with people writing exams on their phones, so you have to find yourself a computer to do this, okay? If for some reason you have a problem while you're writing the exam, email me. There's my email address. It goes to my phone. I will help you out right away, okay? Don't wait till there's 5 minutes left in the time for writing the exam and send me a panicked email. I can't really help you at that point. Email me right away. Okay, and no matter what, communicate with me. All right, remember, I can't help you if you don't communicate with me. So I'm not sitting here going, ha ha ha, how can I make this hard for them? That's not my goal, right? We're just here to learn, and I'm here to make sure that you're learning. Okay, so I hope you do well. It's next week. You got time. Don't panic, but do your best. Okay, bye.